Welcome to our Reading Data with Pandas course. This is our first lesson, and before I jump directly into it, I want to give you a quick introduction about what we're going to be doing in this course. We're going to be reading data from multiple sources into Pandas, as the name of the course implies, but we will also be pushing these data to outside of the Pandas spectrum, right? So the first objective, reading data, means that we're going to take this external data that it's sitting somewhere else, we don't know, we're going to see a wide variety of multiple sources of data. We're going to get that data into Pandas, into the Pandas data structures that we know already. Series, data frames, maybe NumPy arrays if we need it, etc. So that's the first step. We will also export this data. So once you have data that it's within a data frame, for example, how can we export it? How can we export it into a file, push it to a database, etc. So these gets me to the multiple sources we're going to be talking about. So this first lesson, for example, will deal with CSVs and text files. Anything that is about a text file, which is within your own computer, is on the, I would say, simple side of the spectrum of reading data, right? So we start getting external data from a file that it's sitting in our own computer. We can see it, we can browse it. Probably in terms of size, it's nothing crazy, right? It will accommodate your current hard drive. How much can it be? 1 terabyte, 2 terabytes, 100 gigabytes. Again, everything is manageable within those sizes. So anything that is within your computer, any local file, it's going to be within the simple spectrum. And we're going to start with these. We can think about these local files as CSVs, text files, Excel files, JSON files, pretty much, again, anything you can interact in your local computer. That's going to be this first lesson. We're going to talk about CSVs and text files. But then we're going to keep increasing the complexity, and we're going to talk about reading data from databases, for example. So that might involve a network request, right, to reach that server that is somewhere else, with all the complexity that involves, because it's not just the query language of the database that is usually SQL. So it's you have to learn about SQL, but also you have to keep track of the connection. How are you gonna get into that database? Do you need special credentials? Do you need to be inside a private network, etc.? Then we can get data from, for example, an API, right? So it's a network service you're querying to get data from an external source. That also involves a network request. There are multiple things can go wrong with a network request, from not having the right permissions to failing the network mid-request to being a too large size, etc. There are multiple issues there. So again, we're increasing the complexity. And then we have everything that it's related to more like big data, HDF5 files. We have anything that could be in a BigQuery database, that it's Google's, right? So any of these Amazon Dynamo databases, anything that is considered to be big data. We can also talk about big data databases, right? Like, for example, Apache Cassandra, right? That's a good example of a big data database. It's still a database, but it's kind of in another category altogether. So we're not gonna get there. We're gonna stop at all these manageable sizes that can fit within your own data frames. But again, I want you to understand the whole spectrum of all the different sources of data that you can get. And remember, it's not just about reading it. Anytime you're reading, usually you also have a writing, right, operation. So you have to be able to also export these data to any of these other sources. There are multiple things in between. There are, for example, share files, structures, right? So LDAP, your own company can have a private network and you can access a given file server. So all these will increase the complexity, not so much for the way that you're gonna read the data, because Pandas has a very good API, it's very consistent, but more of the external factors that come with reading these external data, network requests, permissions, correct hosts, private VPNs, networks, etc. So all those external complexities will be the ones added. The ones for Pandas, you're gonna see the API is very concise, and once you start reading data, you're gonna see that reading a CSV has pretty much the same syntax as reading a SQL query or a JSON file or a network request. So with all that said, we're gonna get started. Again, we're in the easy category now. We're gonna read CSVs and TXT files, text files. CSVs and text files, the advantage of them, aside from being regular files that are within our local computer, is that we can browse them, we can see them, we can open with an editor, we can open with Excel, for example, and we can see these files. This is the big advantage. So let me show you the files we're gonna be working with. We're gonna have these BTC market price, just price of Bitcoin, and we also have these, which is XM review. On purpose, it's small files, but we wanna show you a couple of complexities, especially with delimiters or separators that we're gonna deal with today. I want to focus on this one because it's probably the most common type of a CSV file. CSV stands for comma separated values. In this case, we have a comma as a separator, obviously. And again, we can see this file. We can open it up. It's text. We can see it with our own eyes. There are local files, which I would say also fall within the simple category, that are local, but they are not text-based. They are binary, like an Excel file. You can't open an Excel file with an editor, okay? You can't just see it. You can indeed see one of these CSVs or of course text files. And you can also open CSVs, for example, with Excel. So I have the same file here in my Excel, right? So I can just browse the data here and everything I can see within an Excel spreadsheet. Basically, a CSV is a table which plays very nicely with Excel, as you know it already. And again, text, in this case, I'm on a Mac, so I can use the regular text editor to see this other file that I have right here. So let's get started. For you to start working on this course, you have already probably gone through the file management course with Python. And if you haven't, please go back again and check that course. It's very short, concise, and it's important for you to understand how to manage files before jumping into this course. Why? Because Python has the basics of managing files. This thing we talked about, text versus binary. Within the text part, you also have to talk about encodings. There are different encodings, Unicode, ASCII, UTF-8, UTF-16. There are different encodings, there are different types of text, binary, so it's important to understand all these different. So again, if you have gone through that course, you know already that we can open any of these files without pandas. This is just reading data with Python, right? Just Python, pure Python. We can open this file with the open statement and function. This statement, coupled with a context manager, right, ensures a safely operation of these files. So what I'm gonna do here is I'm just gonna print what FP is. It's usually, we call it a file pointer. So we always use open as FP, file pointer. And basically this is a file pointer to BTC market price. That's an open file within the operating system. And it has a mode, in this case it's reading. It has an encoding, we were talking about that before. And it also has within it a position. If you go through that file reading course with Python, file management course with Python, you will know what I'm talking about. So we can just read this data directly. I can read, for example, a couple of lines from it. I'm just reading using the FP read lines function. I'm reading the first 10 lines. That's it. So I could somehow manage to pull this data right into Python without any pandas. It involves an open statement, it involves a sort of iteration, realizing when the file is done, checking about the header, what happens if the header is there or not. How can we split the data, right? So we have this entire line, we're writing this entire line into Python. How can you split it between the date and the price, in this case here, date and price? Well, you can use a regular string managing function like the split method, split in a comma, and you have your two values. So we were writing the whole line, now we're taking an extra step to split it into the multiple pieces we have with the CSV. In this case, we have only two parts, timestamp and price, and we're just printing and separating them as you can see them here. Let me put a quick asterisk within this lesson, and it's as familiar you can be with Linux, right, or the counterpart in Windows, all the command line tools in Windows or a Mac, is going to be very important when dealing with files. Why? Because command line tools have these quick tools, right, programs that will help you quickly access data within your computer. So you can browse things, right? You can browse using your terminal and quickly do a cat, a head, a tail, using V or Nano to quickly inspect the file. That's going to be very helpful. That's it. So moving forward, what happens when we have this file that doesn't have a comma as a separator? In this case, we were hard coding the comma. That will involve us changing the code. So we have to keep changing, include as many variables as we have. There is a level of complexity of doing pure Python. We can go one extra step from Python to the CSV module from Python. So this is still pure Python because the CSV module is part of the Python standards library. So we're good there, but we're not just reading data with just lines, splitting them. We are taking advantage of the CSV module. So I'm gonna import the CSV module and I'm gonna instantiate a CSV reader with the file pointer. And the CSV reader is the one that it's taking care of splitting these values as I need it. So in this case, it just splits it automatically by just iterating through the whole file. What happens if we have this other sort of file which has a header and it also has a different separator? Well, the CSV module already accounts for that. We can set the delimiter to be this greater sign, and we will need to, in this case, skip the header right there. But then everything will work, I could say, in a rather simple way. So far, this is a lot better than just pure Python. The CSV module helps with this. But we're gonna take an extra step and we're gonna see how this all improves once we get pandas into the combination. So pandas has a few read CSV, read JSON, read XML, read TXT, read Excel methods, as you can see right here, that have a very consistent API. That means that usually the parameters are the same. Of course, there are differences between reading a CSV and an HTML page, but the APIs are as consistent as possible, and they are usually coupled with the to CSV, to JSON, to HTML methods. So usually by understanding this pattern and understanding what file types are supported, you can indeed read or write to and from these different file formats. We're gonna start first with the read CSV method, and I wanna show you how many options you have. Again, the API is gonna be usually consistent. There will be as much as possible the same parameters, but each different type will have its own things, right? So for example, a CSV, we saw that it can have a custom delimiter. That doesn't happen, for example, with a JSON file. So the read CSV method will have this separator delimiter parameter that is not present in the JSON file. Actually, CSVs have a ton of things to customize. Some CSVs have a header, like Exxon Review, for example, does have a header. First name, last name, etc. BTC market price does not have a header. The first line is data. It's not a header, it's data. So delimiter, if it has a header or not. Sometimes there are blank spaces within your CSV. There are multiple things you have to account for. So all those our different parameters will be passed to the read CSV method. So let's get started. Here's a quick reference of all of them. What we're gonna do first is I wanna show you this consistent API from Pandas will let you read data that it's locally stored. Like I'm gonna start with this one, for example. It's our BTC market price one, or it can be data that it's remotely stored. So if you open this URL, I can do it very quickly here. If we open the URL, you will see that this is a CSV file that it's living somewhere else in a remote server, and I can access directly within Pandas. So the syntax is pd.readCSV, and you pass something. This something can be the location in a local file or it can be a completely remote location. Like in this case, this is a URL, and it will work in the same way. This is very good. You don't have to worry about where the data is living. Pandas will import it regardless of that. So that's very useful. We're gonna see, we see multiple things here, right? So for example, this one was perfectly parsed. This is just a pleasure. We have the header, its comma separator, country codes, etc. So this is it looks very good. Everything was parsed into a data frame without any worries. This one, on the other side, has a few issues, right? So we have invalid data that we will have to clean somehow. But also, what we have is that we don't have a header. We know we don't have a header within this file. And Pandas assume that the first line is a header. So these are all the parameters we will be passing to read CSV in order to improve how the file is imported into this data frame. So the first thing is we're gonna pass header equals none to fix that. That's the first step. And we don't have a name for the headers yet, but we see that the data is parsed correctly. The first data point that we have corresponds to the first price that we have, $10.99, right? So that's the same thing. What happens with missing values? What happened with these question marks, with the dashes, etc.? What can we do? Well, we can pass an NA values parameter that will make Pandas parse those values as not numbers, right? Remember from our Pandas course, NumPy course, not a number is pretty much a missing. It indicates that's missing data. This is also related to the data cleaning course. Don't worry, this is just missing data. So instead of having question marks and dashes and empty strings, etc., we just replace everything with NaN. That again means that the value there, that data point, is empty. We can improve a little bit our data frame to make it easier to read and manage, passing names for the header, right? So each one of the columns has a name. In this case, just completely custom. We decided at timestamp and price. It will set those column names for you. What about column types? What is a timestamp? What is a price? If I show you df here, df.info, we're gonna see there that timestamp is a string, and we have successfully parsed price as a float, right? So float is good for a price. A price is a numeric type, and we were able to do this by passing NA values. If you don't pass NA values with a none, it will not work. So now that we have NaN values, price is a float. What about timestamp? Timestamp so far is an object, which basically means is a string. We actually want a datetime here. We want correct type for each one of the columns. Timestamps, datetimes, prices should be numbers, etc. So in this case, country is going to be a string, but we want year to be a number and we want value to be a number, right? So we want the correct type for each one of our columns. How can we do that? Well, we can hard-code it, right? So this was already in place, but we're gonna see it again. We can hard-code it saying the type of the price is float, and we can try parsing the dates of the timestamps, right? So for example, these toDatetime function will parse the timestamp, it's pretty much what we have right here, into an actual datetime value of Pandas. So we can do it manually. We can just set df at timestamp equals pd.toDatetime, right? We can set the value as a result of this transformation of types, and this is going to work. But we can also pass that to the reader to the readCSV method. We can say price should be a float, but also I want you to parse the first column equals 0, as a date. Right? So df now contains timestamp as a date. This is exactly what we were looking. Now price is a float, it's a number, and timestamp is a date. This is what we wanted. So you can see here how by improving and passing more and more parameters, we're customizing the way we read out CSVs. Don't worry if you think that this is too much. It's actually not. We keep adding parameters with time, but the good news is that you can quickly learn these parameters as you're using them, and usually you're from within the type of work you do, the parameters will be the same, right? So for example, your company never exports headers for files. So you know already headers is none. So you can accommodate these simple needs for you. You can probably refactor them in external functions and you're good to go. So there is no much to learn there. It's important to mention that you can always access, you might know it already, the documentation of a method. In this case, we're going to do read CSV from within a Jupyter notebook by appending, or actually prepending, I prefer appending a question mark and executing the cell. So in this case, you can do read CSV with a question mark, and Jupyter is going to print the signature of the method, what are the parameters received for the method. And again, you can see CSV is crazy. There are so many parameters that it receives, but also the documentation with the explanation of what each one of these methods is doing. So in this case, we know header can be an integer, so it can be the row number. This is something we hadn't seen before. As we are looking at the docs, I can mention it, but we didn't have the need to know it. It can be a list, it can be the default, which is infer, or as we've done it, we can pass a none. Header equals none is without a header. So again, it's just for you to remember that whenever you have a question, how do I do this thing? You can just print the docs and read through them. So what about the index of this data frame? What is the index? In this case, you see that there is no index. Actually, there is an index, but it's a regular range numeric index, pretty much useless. We know that each one of these prices correspond to a given date, right? So this is April the 16th, this is April the 15th, etc. So we wanted the timestamp to be the index. We can set that also with the CSV method. So we can say the index of this data frame is going to be the value at column 0, the first one. And now timestamp has its still named timestamp, it's still a date, and it's now the index. So everything working as expected. We only have one column, which is price. You can say here on the side that this could probably be a series. There is a way to read a CSV into a series instead of a data frame. Look at the docs, as we were saying. So what about this XM review CSV? We've seen B2C market price, simple enough. It's just separated with commas, doesn't have a header, a few tuning here and there, right? Just changing the names because we don't have the header, saying that we don't have the header, working with no values, etc. We're gonna see now this other example that it's a little bit more broken. We could say there are empty lines, there are different separators, etc. So it's just gonna be step by step. You can follow it later. Basically, if I try reading this thing, it doesn't work so well, right? It's like everything, it's very ugly. Pandas doesn't realize that this is the separator, so everything's just this huge, ugly data frame. So the first thing we're gonna do is we're gonna change the separator. Remember the CSV module treated as delimiter, in this case gonna be separator, sep. And in this case, we're gonna say it's the greater sign, and automatically we can see that it works very well, right? Just out of the box, parse everything as expected. It automatically clear the blank lines, and everything that was within quotes was parsed as it should have been parsed, in this case as a string, depending on what you want to get. All these things that I have mentioned are part of the customization of your read CSV. You can see that there is a parameter will set what type of quotes do you want to parse, if you want to parse them or not, etc. That depends on your own settings. So moving forward, we have here the data frame. We can see what are these types. These are strings because again, these are quotes. And moving forward, we can specify what is the decimal separator for numbers, right? So now we can see that these are floats. And why is that? Because not everybody uses the same notations. For example, in Europe, the comma is the one used for decimals and the dot is used as a thousand separator. And any powerful library as Pandas should be able to accommodate data coming from not just multiple sources from a technical perspective, files and databases, but also from multiple countries, locations, right? Settings that people are using to store their data. In this case, we're also using the thousand separator right there as a comma. Moving forward, we can see more different parameters. In this case, skip rows, right? Skip rows equals 2. We'll skip the first couple of rows. In this case, Ray and Melvin are out of the equation, right? They're just skipped over. And you can skip individual rows like first, third, etc. Just more parameters. What about skip blank lines? Automatically or by default, this line, as we saw, was skipped. It wasn't read. You can change that with the skip blank lines equals false. So now that entire line is read as a null value. Loading specific columns, we can just get a few of them, not all of them, right? We say, I only care about these 3 columns, leave everything else outside. And as I told you, we can, let me show you what it looks like there. We can read something directly into a series. So in this case, we're using just one column, last name. We can read that exam test2, in this case, exam test2. We can read that into a series using the squeeze equals true method. And you can see it's a series. So far, what we're saying is that there are multiple options to read data from CSVs or text files. I don't want you to remember all of this. Seriously, I don't want you to remember or memorize these options. I just want you to know that there are a ton of options you can choose from your CSV files. So hopefully your files can be as clean and as standard as possible. Like this file. This file is clean. This file is standardized. It has a header. This is perfect. You can just do read CSV, no parameters, and you're good to go. If that's not the case at any particular moment in your work as a developer, as a data scientist, I want you to know that you have all these options. You can go to the docs, and there are multiple ways to customize it, and the Pandas accommodates those needs. It doesn't fall short. That's a good thing about it. So we're done with reading. We've seen just a few parameters. There are more, as you have probably guessed, but we're gonna now go into saving this data from the Pandas structure into a file, a CSV file, in this case, a table file. So we have this data frame, right? The one we have correctly read. And the method is extremely simple. We're gonna do a toCSV method. This toCSV will print out, it will return a string with the correct structure of the file. Usually we don't want to just print it, and sorry, but usually CSVs are very large. In this case, we have a very simple example. But what we can do is just execute toCSV with the out.csv parameter, and I'm gonna open it with the editor. It has just saved the file. I'm gonna go back again to the first part here in a second. But what you can see here is that the header was indeed printed. So that's good. The header was printed. It is using standard commas. You can change that, but it's using standardization. It's also using standardization for numbers, as we didn't have before. Now, why do we have this empty thing here, 0, 1, 2? Well, because exam data frame was a data frame that had an automatically generated index, 0, 1, 2, right? A range index automatically generated. What does this thing mean? That when you do a toCSV, the index will also be exported. And the index doesn't have a column name, so it's just empty. But the index is there. We can choose to avoid saving the index by doing index equals none. And now if I reload this file, we're gonna see that the index is no longer there. So this has been our introduction to reading external data with Pandas. We again saw in depth the read CSV method. We didn't see all the attributes that it accepts, but again, this idea that there are multiple things to pass, that's the important part. And we have also seen that you can read and you can write too. We're gonna keep moving, making progress, reading JSON files, reading Excel files, and then databases, etc. In our first lesson about reading CSV and text files, I told you that that was probably the simplest form of external data. It's both contained in your local computer, in your local hard drive, and it's also text-based. So you could just open it and read it with your favorite editor, with a command line tool, etc. You can just open a text-based file and look into it and see what it contains, what's the form of it, etc. With Excel files, the subject of this second lesson, it's not so simple because it is contained within your own computer in your local directory, but it's a proprietary non-text format. So it's not so simple to look into an Excel file. So we have a spreadsheet here we're going to be using, and if I look at the contents of it, it's not so simple to make sense of it, right? It's just like these old characters, which is a proprietary file structure of Excel, of Microsoft Excel. And why you would like to work with these files? Well, it's very common to get these from, for example, data analysts, etc., people working with Excel that just somehow produce these spreadsheets. Ideally, you can transform Excel to a CSV. You can export an Excel file as a CSV. So as much as possible, you should ask your coworkers or whoever is providing your data to export it as CSV. It's a lot more stable and it's easier to work with. But if that's not the case and you have the spreadsheet, we can read it with Pandas. And actually, to give you a little bit more details, right, to learn the internals, Pandas will be using a few other libraries. You can actually look it up in the requirements.txt file in this project. But what you will see is that, again, Excel is a proprietary format. It's not so easy to read into it. So there are libraries that are reverse engineering the Excel format so it can parse it using Python. There are multiple ones. Every language has a library that does this. And in this case, Pandas, again, it's not directly parsing the spreadsheet, but it's actually using one of these external libraries that we are mentioning. So moving forward, we're going to introduce the read Excel method. And again, this is the consistency of Pandas. As we have read CSV, read JSON, we'll have read Excel. Okay, it has a few parameters. The first one is the file path that, as we saw in our previous lesson, it can be a file in your local computer, probably the most common type, or it can be a URL pointing to the remote location of an Excel file. So let's get started with it. We're going to work today with these products.xlsx, and I'm going to open it right here. Is the products file. It actually contains 3 sheets: products, descriptions, and merchants. And by reading, just doing a read Excel method, what you're gonna see is that what we read is the first sheet of the file. And let me open up. There you go. Product ID, price, merchant, brand, name, etc. This is what Pandas is parsing. What you can see here is that it's very well parsed, right? So it's perfectly imported from the tabular structure of the Excel file. So far, reading data from the Excel file works very well. Things get a little bit more complicated if your Excel files have more advanced features like macros or formulas or some sort of formatting, hiding, etc. So, but just reading the structure and the data works perfectly, as we can see in this example. It's perfectly parsed from the spreadsheet into a regular Pandas data frame. So you can see that the header is parsed correctly, and we can skip that if we want. And also the index can be set. So in this case, the index is set on a range index, similarly to the way Excel treats row IDs. But we can also specify that we want to use one of the columns as index. So now product ID is the index. As I mentioned before, automatically by default, when you execute read Excel, the first sheet is the one parsed and pulled, products in this case. But we can use the second parameter of the read Excel, which is the sheet name. And in this case, we're gonna say that we wanna read products xlsx is a file, but we wanna read the products sheet, which is right here. What happens when you have multiple sheets? You can't read them all at once using the read Excel method, because each sheet corresponds directly with one data frame. So you need multiple data frame. That means multiple variables, products, merchants, descriptions. Each sheet is going to have its own data frame, right? So you can't do everything at once. You will have to execute multiple of these methods, read Excel, containing different sheet names for each one of them. So let me show you merchants too. So it's very common to either keep different variables, products, merchant, descriptions, or keeping some sort of a list, right? So sheets in my file at 0, 1, 2 contains products, merchants, and descriptions. There is an alternating way, which is using the Excel file class. So these in this case, you're gonna pull the entire file as a structure of the file. It's like one level up, higher level functionality. And in this case, the Excel file class will create this Excel file. Let me show you what it contains. Right there, Excel file. And it will give you information about the structure of your file. In this case, we can consult the sheet names associated with these files. So we see products, descriptions, and merchants. We also see that they are in the order we have it right there. So from here, we can say from this file, now parse products, for example, this sheet, and we get products as we go on. Parse receives the same parameter as read Excel. They are pretty much synonyms now that we have imported the Excel file. But again, the advantage is that you have each one of the sheets names contained in the same file structure. Now, once you have somehow pulled the data, in this case, you have constructed a data frame, you can write it out, right? You can write it to a Excel file. So again, ideally, you're gonna write it to a CSV file that can be then imported by an Excel program, but you can also write to Excel if you want. And in this case, the method is convenient, and it's an intuitive API. Again, to Excel out.xlsx is the name we're giving, and we can read it, and it looks in the same way. We can just set the name of the sheet, etc., all the things we can do with them. There are more advanced functionalities to this writing procedure, right, to the to Excel. And it says, for example, that you can shift either down or to the right the position of your writing, right? So in this case, what we can do is we can write the same products data frame to the same file, same sheet name, but we can shift the starting row, right, 1 below, and the starting column 2 to the right, right? And I have already parsed this file. I have it right here. You can see that there is one empty row here and there are 2 empty rows here. So this might be convenient if you have some sort of process already set with, I don't know, a coworker, etc. What happens if you have multiple sheets to write? We're gonna use what we call an Excel writer, right? So you have, again, 2 simple methods, read Excel to Excel, and then you have 2 more advanced classes, Excel file to read multiple sheets at the same time, or actually to parse the entire file, right? And we also have this Excel writer to write more complex Excel files containing multiple sheets. So we're gonna first instantiate the writer. So far it hasn't done anything, just instantiated the writer. And now we're gonna say we wanna export these products data frame, but we wanna use this writer. So instead of regular file name, we are passing the writer, and you're gonna see that it works as expected. And the same thing can do here. We wanna write this merchants data frame using the Excel file format, and this is the writer. So now it's all working in the same way. Usually you're gonna create an Excel writer using a context manager and just write all your data frames to it and be done with it is the safest way, because it's going to open and close the files we know already from the file handling course. So again, so far you can read Excel files pretty easily. If you have issues parsing these files, is because usually they have some sort of macro or more advanced formatting or more advanced formula that makes it hard to parse, right? It's not so deterministic at the moment of writing. As much as possible, you should try to avoid reading and writing from and to Excel. This is kind of an advice from experience. If you can, you should try to always communicate with CSVs. If someone, a coworker, is working with Excel, please ask them to export it as CSV. You're gonna parse the CSV, you're gonna do all your data frame modifications, all your work, and then you're gonna export it if you need, or export your results in another CSV that will be parsed by your coworkers. Ideally, try to work with CSVs is possible. This is everything we're gonna do with Excel. You can see you can parse multiple sheets. It's a very powerful feature. And we're gonna move forward with other formats, including JSON soon. In this lesson, we're gonna see how to parse JSON structures. We're gonna use files, right? Local files, locally contained files. But JSON is actually a format that it's very common, very popular as responses from API calls or network requests. So whenever you are requesting an external service over the network using some sort of RESTful API, the response is gonna be JSON. It can be XML, but I'd say 90% of all the services that I personally use are JSON. So for example, the Twitter API, Reddit API, Facebook API, any sort of API that's online will usually have a JSON representation. So again, we're gonna use local files so we can say it, but it's very common again to get JSON representations from the network. What is a JSON format? This is what a JSON file looks like. JSON is derived from JavaScript, and it actually has a very compatible syntax with regular JavaScript, with this combination of literal types, like for example, strings, integers, booleans, and objects, right, that are these key value structures that look a lot like a Python dictionary, and also sequences, like in this case, a list. This is a very common JSON object, the one you're what you're seeing right here. It's a list of multiple records structured or standardized as a set of objects. So in this case, you have for each one of these objects, which represent games, you have different columns, records, variables for them, title, price, content rating, etc. And the way they are structured is by just concatenating each different object, right, in their own structure. So this is different from a CSV, where it's gonna be a more tabular structure, and there's gonna be just one table name at the top, like a header, and then all the records below. In this case, all the variables, the headers, are repeated for all the individual objects. The good thing about a JSON file is that it's more readable as the regular text format. You just can open it up, and it's a little bit more intuitive, at least for me. It's a lot simpler to understand what's going on in it. And this is actually the source of the popularity of it, why so many APIs are using JSON files to return their data. So let's get started. We're gonna use again this games.json, and the read JSON method from Pandas is extremely intuitive, just as you would expect. Read JSON, and it will open it as a data frame as expected. All the values seem to be parsed correctly, so seems like we're good to go. Well, there are a couple of issues with JSON, and it's that it's a deeply nested. It can have multiple hierarchical nesting or levels within a JSON file. The way that I showed you these games.json file before was with the regular text format. But there is an alternative, and actually it's the default way to open a JSON file within Jupyter Lab and other tools, which is the tree structure. And it's called tree because it's a nested format. In this case, the root is just a sequence. It has 193 items, and it's exactly what we're saying right here. The root of it is just a sequence. Within the root, we have 193 leaves, we could say, as in a tree, and that's it for this simple JSON file. We can say that it's even a flat structure. But we're going to move forward now to another file, which is a users.json file. In this case, the root is a whole document, an object, which has one key, info. Within the info, there is a sequence of multiple individual objects. So we could say this is already level 2, one object. Within the object, we have ID, name, username, email, that's good, but then we have address, which is another sequence with nested objects within it. So what we see here is that a user can have multiple addresses listed because there's a sequence. We can have 1, 2, 3, I don't know, as many addresses as you need it. And also we see that an address contains geographical position, latitude and longitude, right, that are nested within the address key. So we go we go root, info, sequence of objects from one object. We go to address. From address to sequence of objects. The first object contains a geo position. So we go deeper and deeper and deeper in this tree. If I show you in the tree visualizer of Jupyter Lab, we're going to see the root, which is a sequence, has only one key, info, which has 10 items, 10 users, we could say. For each one of these users, we have ID, name, username, email. We see address, which is another sequence, right? In this case, it contains only one item, just one address for this user. And then within the address, it says phone, website, company, and within the address we have street, suit, cities, zip code, geographic position, and we keep going deeper and deeper and deeper within our structure. Now, I want you to think how you structure this thing in a table. It's rather impossible, right? It's not simple to do it. So we're gonna see a few tricks to work with it. The first thing I want to show you is how it's going to work with pandas by default. By default, it will not work. Sadly, you're just trying to import this thing, and it's importing the whole dictionary nested within the data frame. It just doesn't work. We can parse the dictionary within the JSON library built into Python, and we can see the structure of it, and we can inspect the keys, the values, etc. of our dictionary. We can print all the users with just regular Python. What we're doing here is we're trying to make a little bit more sense of the structure of it. So what's going to be the key to parse these deeply nested objects? Well, we're going to use the from dict method of pandas. So in this case, it's pd.dataframe from dict. So it's a class method. Remember your object-oriented programming course. A class method of the data frame, right? Which it receives a dictionary of objects. So in this case, very simple object to use, and we can change the way these objects are oriented, right? So we could say like vertical or horizontal if you want, like X or Y axis, etc. So that's going to be the key to parse these file. If we get the default one, we still see the ugly one, right? So we use from dictionary, just pass the entire dictionary. JSON dict comes from this JSON dictionary that I have parsed using the JSON module in Python. But we can see that we can change that by doing JSON dict at info, passing the first parameter in there. So if I show you again the tree planner, the tree visualizer, we can see a user contains ID, name, username, email address, etc. And we have it everything almost perfectly, except that address and company are still nested within each one of those columns. So there'll be ways for you to extract those nested structures using some pandas methods and some string manipulation methods, but there are better ways and this is kind of the final section of this lesson, where we go to the JSON normalize function. This function is very powerful, has multiple, not so many parameters, but a few that will completely change the way it works based on some preferences of your files. It all depends of how your file is structured. What's the structure of your JSON file? And I say file because, again, we're working locally. It can be a network request. So we're going to use the JSON normalize function, passing the entire dictionary that we have parsed with the JSON module. So parsing this will get you just this gigantic data frame of users. If we go again inside this nested structure, we are gonna see pretty much the same structure as before. Address is nested, but company is not nested. It has these separators where it says company.name, company.catchphrase, and company BS. So let me open it up. We're gonna bring users closer. If we forget about address, we see that company has just one level of nesting, and we see name, catchphrase, and BS, which, there you go, it's all spread out or extracted, whatever you wanna call it. The JSON normalize method, what it's gonna do, it's gonna extract the nested structures, right, into a tabular format in order to flatten out the entire data frame. So in this case, address still keeps in the same way. We're gonna see a way to fix that. But for this one level nesting one, company, we see that everything has been already fixed. Company.name, company catchphrase, and company BS. We can change the separator for that. So instead of being a dot, we can use an underscore, whatever you want to use. Just we're going to keep using underscores because it reads better, but it's just a preference. And we're going to see how we can fix address. So here, we're going to pull only the address field. We're going to say the record path is we are already within info, we're passing info. Remember, we have an original dictionary or an original JSON file, which is this whole thing, this whole root, and then we zoom into info and just pass info. So we say the record path is for each one of these objects, I want you to get the address of them. But what happens if you want to pass the entire dictionary? It's going to work sort of like a path. You pass each one of the keys that will drive the structure of the JSON until that given key that you want to use. So if I pass the entire JSON dictionary, I say first go to info and then go to address, and we get the same result. So we are denesting, if you want, these objects. What are we going to do right here is we are parsing the JSON file, but we're using the meta parameter, which will use the ID, right, provided by the outside objects. So in this way, we could have all the users in one data frame with their IDs, right? Each user has an ID. This is the ID of the user, actually right here. And then we can extract the address with the JSON normalized record path address and get the meta ID separately. So now we could merge these two data frames together based on these different keys. Finally, how to save these JSONs. This is extremely simple. It's a 2JSON. As we had a 2CSV, a 2Excel, now we're gonna have a 2JSON. That what I want you to see is that the structure can be a little bit odd. All right, so this is our nested structure, and we're gonna use a 2JSON. Well, this doesn't make much sense, but we're gonna use a 2JSON to out.json. We're gonna look at it. Like, let's refresh and see this tree structure. It has a root, and now what you're gonna see is rather strange, is that the way JSON keeps this data is by flipping the individual records into different records per column. So it kind of tries to simulate a CSV file. That's the standard way in which Pandas will export JSON files. It still works. I can pull it. As you can see, I'm directly reading from out.json, but the way it exports it, and I recommend you to look into the documentation to change this behavior, which is of course possible, but the way it's gonna save it or export it by default is with these kind of odd format for a JSON file. This is not the way we usually store JSONs, but again, it's a familiar method or format for Pandas. So again, reading JSON files is not complicated from a technical perspective. It's just a text file. There is this read JSON format. The complexity relies on the way JSON files are stored, right? So if there is too much nesting, it's hard to flatten out these structures. So I recommend you to look into different examples, and any time that you are going to work with a new JSON, I can guarantee you're going to spend some time making sense out of the structure of it to understand what's the best way to parse it. So just focus on the structure. The technical way of writing it is rather simple with either JSON normalize or from text, or hopefully just a read JSON. Now it's time to show you how to read data from relational databases using SQL, Structured Query Language, which is the language that all relational databases use. MySQL, Postgres, SQLite, Microsoft SQL Server, Oracle, of course, all the relational databases will use SQL. So Pandas has a read SQL method and also toSQL method as expected. Let me tell you something. It's very important for you to go back to the Introduction to Databases Using Python course if you don't remember SQL, because what we're going to show you here is how to interact with databases. We're not going to dig deep into the queries we're going to use. We're not going to dig deeper into SQL by itself, right? The queries are going to be very simple, just to show you the type of methods you can use in order to pull data from the databases. But again, the SQL queries by themselves will be pretty standard. So the first thing we have to talk about is we're going to be using this sample database right here, Chinook. Is a very, very common database with artist information and rentals, and it's very, very, very straightforward. You can look at the database diagram to have a better idea. We're going to be interacting with employees and a few other tables. It's very straightforward. We're going to be using SQLite 3 so we can store the database locally in a file. But what we're going to show you here will also work for other type of databases like Postgres or MySQL or Oracle, etc. So the first thing we're going to do is we're going to go back again. We're going to do a quick refresher of how to read data using pure Python, right, from a database. So we will not be using Pandas yet. I just want to give you a quick overview how we used SQLite 3. And remember, as we use SQLite 3, we could be using a different driver like PsychoPG, which is the Postgres one, or the one from MySQL, etc. So we're going to import SQLite 3, and the first thing we're going to do is we're going to create a connection to the Chinook database. This is usually, when we're interacting with databases, the most complicated step, because it might involve hosts, users, passwords, database names, private VPNs, etc. So getting a connection to a database can be difficult in your work, whatever is your setup. But once you have connected to it, then it's pretty straightforward. So what we're going to do now is create a cursor, right? The cursor object that is used to submit queries to the engine, which is working behind this connection. And the first query we're going to submit is a very simple select star from employees, limit 5. We just want 5 employees back. This is, remember, pure Python's API to deal with a SQLite connection. Once the query is executed, the cursor returns, and we can do a fetch all to fetch all the results. Remember here that there are several methods: fetch one, fetch many, fetch all. You can go look at them at the documentation. It also might change depending the driver you're using for MySQL, for Postgres, for Oracle, etc. So again, this is the way we interact with pure Python. Here, what I can do is I can look at all the customers we're receiving, right? So it's a list of tuples: ID, name, last name, position, etc. All the data from our employees. And now that I have this list of tuples, I can use that to create a data frame, right? So I can just instantiate a data frame. I don't have column names now. Remember that there was a way to change the way your results were constructed to return dictionaries. Again, go back again to the Intro to Databases course if you don't remember that. And that's it. We have just created a data frame out of SQL results. But we haven't read SQL from Pandas. We read SQL into a Python data structure, a list of tuples, step 1, and then we constructed a data frame from that list of tuples, step 2. Pandas never directly talked to the database, and that's of course the objective of this lesson. So moving forward, we're gonna close our connections. We're gonna do pretty much the same process, but now 100% from Pandas. We instantiate another connection so we can start fresh, and we're gonna use now the read SQL method. The read SQL method receives the first parameter is the query that you're trying to run, and the second parameter is the connection that it's gonna use to run it. So in this case, I have just literally passed the query, to Pandas. Pandas is taking the connection, executing the query, getting the results, and storing everything in a data frame. And as you can see, it works very nice, right? It's just pretty much as you'd expect. You have column names, you have the index, everything is set up. You can do a couple of, as a read SQL method, the idea is to simplify our task. We can include a couple of parameters to the read SQL method so we can improve the way the data is read, right? So instead of setting a range index, we can say, please make employee ID the index of this data frame. And please try parsing, for example, birthday and hire date as dates. So now everything looks pretty much the same aside from the index, but you're gonna see that these are datetimes. So with this way, you can change the types that are read, what's the index. Again, there are multiple things to change. You can look into the read SQL method documentation. So everything is pretty much the same. Now, what happens? Read SQL, and these might trip you if you're just getting started with all these. It's usually what confuses beginners. Read SQL is kind of an umbrella method in Pandas that tries to cover every case that you have. But underneath, read SQL is actually using two separate methods from Pandas that are read SQL query and read SQL table. Okay, read SQL query is the one that it's actually being run or executed here because we're passing a query. So read SQL notices that this is a query and immediately invokes the read SQL query method. So if we try here read SQL query, it's pretty much the same code as before. Instead of read SQL, you're gonna look, everything's gonna look the same. Everything is pretty much the same. So we can see read SQL query is pretty much the same thing as read SQL when using a regular SQL query. And why, you might ask, why do we have this read SQL and why do we have a read SQL table? Well, this example of us doing a select star from given table is something that happens a lot. We read an entire table. And this is kind of the advantage of Pandas for SQL, for database data processing. Before, and this is kind of an opinionated sentence, what I'm gonna say, is some time ago, we used to have a ton of business logic sitting in our database. We had stored procedures, we have triggers, we have views, and things got complicated. We had a repository somewhere with queries that were hundreds of lines of code with multiple joins, cross products, subqueries, etc. The queries were very, very, very difficult to understand, parse, maintain, etc. With the increase of popularity by Pandas, what I'm noticing, and this is completely personal, I'm noting that there is less responsibility passed to the database engine, right? So there's usually past these flat queries, just give me this whole thing, and there is more processing on top of Python. So instead of doing a complex subquery here, right? So we can pull the diagram and say, let's get all the artists that have tracks that are part of a playlist that was favored by a given customer on this date, a very complex query. Instead of doing that, I see a lot now of just pulling the entire table or entire tables as multiple data frames and then doing processing within Python. So that's kind of a tendency that I am seeing. What does this mean, and why am I telling you this? Because again, if we tend to read entire tables, it's kind of verbose to have this select star from each one of the tables. So this read SQL table method will just let you say read SQL table employees, and that's it. It's gonna read the entire table. And this is the method we're gonna see now. There's a caveat here, which is that to do a read SQL table, you will not be using a SQLite 3 connection, but you're gonna be using a SQL Alchemy connection, which is an object relational mapper, ORM, in the lingo of programming. That is very powerful. It's very powerful and popular. You're gonna see it in multiple places, and it's used by Pandas. So instead of creating a connection which is based on SQLite, we're gonna create a connection based on SQL Alchemy right there. So we first create an engine, and then we connect to it. We have the connection, and now the read SQL table method accepts what's the table name you want to read and what's the connection of it. So now you can see, well, let's use index column equals employee ND and parse dates, all the same that we had. The result is the same as before. But now again, we don't have the select star from employees, etc. We just read one table, and that's pretty much it. So now we close the connection. So that's the difference again between read SQL query and read SQL table. You will use the one that you prefer. The good thing about SQL Alchemy, and this is just a comment on the side, is that an ORM, the responsibility of an ORM is to map, right, the relational model, which is incompatible with the object-oriented programming model. So it's mapping an object-oriented programming model with a relational model, with something in between. The ORM is the glue in between that will let you transfer, and it will let you translate from an OOP structure where you have classes with nested things to a relational model. And that means it will simplify things for us, and it will also talk to multiple different types of database engines. So it will also make the connection and the query language, it will make it transparent regardless of the type of engine that we're using. So now, how can we create tables, right? So let's say we have a data frame and we want to insert it, or we want to create an entire table from that data frame, right? So let's say that these data frame we have right here does not exist in the database. We have just generated it. So now what we're gonna do is we're gonna store it in a new table. I'm gonna make sure that the table doesn't exist. I'm gonna just delete it just in case. And I am going to execute a toSQL method saying I wanna store these data frame under this table name using this connection. Okay, and now I can read from that, and you will see that it contains the names that we require. There are multiple changes you can do here. So you can, right here, you can use toSQL employees to if exists replace, which will change the behavior depending on the way it works. So this will all now make sense. There you go. And there are again multiple variations to these toSQL. To be honest, for me, at least for me, Interacting with a database is 99% of the time it's a reading process. I don't find myself doing these to SQL too often. I just read from a database pretty much all the time, read, process, and again, I am seeing this tendency of replacing the logic, right? Taking it out from the engine to store it in Jupyter, in Python, right? Just Python tasks, which can be committed. It's a lot simpler to debug Python than SQL. You can store it in your source control like GitHub, etc. It's a lot better to use, at least for me, to use Python. Of course, there are times when you just using a good query, right, optimized by the engine, you're saving time. It's a lot more descriptive, right? But again, I am seeing this tendency of reading data into Python, flat data, and processing it on top. What I want to say is 99% of the time you will find yourself reading data instead of writing it. So don't worry too much about these if it doesn't make a ton of sense. So this was all about reading SQL. Remember, go back again to the Introduction to Databases with Python course if you want to refresh your SQL language, your SQL query language, right? So if you want to practice more queries, etc., there are a few exercises, but that's the course that has all the complexity within the queries. In this case, we're just seeing how to interact with it using Pandas. Now we're gonna see how to read data from an external API. In this case, we're gonna use a REST API, so it works on top of HTTP, but this could be changed if you have, for example, a SOAP API or a different architecture. To be honest, 95% of the internet today works with a REST API. There are a few SOAP around, but usually you're gonna be interacting with a REST API, so this is gonna be a very good example. Similarly to what we said with the reading data from databases lesson, the main complexity of reading data from an API relies on the API on itself. The reading part, what we're going to do in this lesson, is going to be extremely simple. There are a couple of read something methods that you're going to use in order to pull that data from the API. Usually, the complexity will rely on the authentication of the API if you need some sort of explicit token, API keys, secrets, etc. The format of the data return. So, for example, it's not the same thing to receive a JSON file from an API, then an XML, then a CSV, etc. But the idea is that once you read the data from these given API or web service you're querying, then you can just use pure Python and Pandas to mix that, to merge all the data you have and somehow reach to this data frame you're going to use to work. So the first API we're going to see is the City Bike API, which is just an open project with bike sharing around the world. You can look into it. It's very interesting. It's built kind of from scratch, thinking about developers. So it shows you how you can contribute to it, etc. And it has some neat documentation that you can explore. The method we're going to use is this v2/networks. It shows all the networks of bike sharing in the world. Okay, so this is the result of that query. There is no authentication, so it's the simplest example that we can think of. To pull this data, we're going to use the requests external API of Python. So in notebooks.ai, it's already installed. If it's not, please go ahead and install it. And the API URL is the same I show you. The simplest form is just to make a GET request. And here, it's important that you remember your HTTP practice. Okay, so you can go back again to that course if you need it. But basically, we're going to do a simple GET request, right? This is the request object. We're going to check that it's okay, status code is 200, etc. And we can see the result, which is pretty much the same thing as we see right here. It's this huge text that it doesn't look a lot like it has any form. For now, it's just text. But the requests API has a JSON method, so you can export you can transform the text that you received into a JSON object just with this method, okay? And it's of course because it's already JSON. Here the difference is that it's text that it's being parsed as JSON. This is what the method does. And now we can dump it and write it to our own local file. This is a completely optional step. You don't need to dump it. I'm just doing so we can say it and we can look at it. So in this case, we have root, we have all the networks. And in this case, we have all the entities of these networks. What are the companies, ID, location, right? Where are them, the name, etc. And we can try creating a data frame out of it, right? And we see that it works, but we probably have the same issues as we had before with these nested data structures. So in this case, location is a nested structure. So we can use the regular JSON normalize method or function, we saw in our previous lessons, and JSON text at networks. So we pass directly the networks key, and we say that we want to underscore separator, and in this case it's location. It's being split out right into multiple parts right there. We can save it to our JSON if we need it, etc. There are a few other examples that you can look in this post. I recommend it. It's using the CryptoWatch API to read financial data. And finally, again, the complexity of all these relies on the sort of authentication you have and the several steps you need to create, to access these data. So this is a very good example. These is a testing site that you can use. I'm gonna open it, and it asks for username and password. This is of course for testing, so it's open. I can go ahead and read it. In this case, throwing a 401 error, right? And there you go. If we show R, we're gonna see the response, because I need to provide a user and a password, and that is provided with the auth key. So in this case, now it works as expected. Remember, the complexity of reading an API, the API data relies on the API by itself, the authentication mechanisms, the structure of the data, if it's paginated or not, which is usually is, etc. Once you get it, somehow, it doesn't matter if it's JSON or CSV or XML, somehow you will be able to put it and import it into Pandas. In this lesson, we're gonna see how to read HTML tables directly from web pages. Yes, seriously. So we're gonna, for example, read these tables directly from the website into a Pandas data frame. It's one of my favorite features for quickly hacking. You know, you have this question in your mind. I don't know, what's the country with the greatest GDP that doesn't something, and you just go to Wikipedia, the table is there, you can import it directly using the Pandas read HTML method, as we're gonna see, and you can start working with it. So it's very, very, very interesting. We're gonna start with a simple string that it's right here, right? And you can see the structure in sample.html contains the same result. The idea is that I just want to use it as a string here, so you see that this method read HTML parses a string, but of course we've seen with, for example, a CSV or a JSON, the actual source can be stored locally, it can be a string, or it can be remotely, and it's going to be pulled. So what we're going to do here is just import these table, right, with the read HTML method. And what it's going to import is not just one data frame, but by default it's going to include multiple data frames, because it's understood that web pages have multiple tables within them most of the time, okay? Not just because you see a table here, but just the layout of the entire web page can be by itself a table. So even if you don't say it, they can be using the table attribute for layout. In this case, we only have one table, simple. So we're gonna just set it as our only data frame. And you can see how we have correctly parsed the HTML table into a data frame. There is no so much to say about this. As usual, you can change pretty much anything in the methods as headers. There are multiple parameters you can pass to read HTML to customize it. What I want to jump into is actually reading a table from the internet. So let me quickly walk you through all these reading data cores and the complexities for each one of the data sources. For JSONs, we said that the complexity relied on the structure of the JSON file. If there is too much nesting, it gets difficult. True, that's expected. For databases, we said that the complexity is writing the actual SQL query. Once you have the SQL query, the read SQL method will just do its work. For API calls, we said that the complexity relied on the authentication of the API, the data return if it's JSON or XML and it's too nested, etc. For HTML, the complexity relies on the styling of these tables. Usually these tables are prepared more for a visual type of user than a programmatic type of users. In this case, we are a programmatic user. We're pulling the data from the web page programmatically in order to use it from a data frame. So that usually doesn't work so well. So as you can see here, the player name is repeated in all of them. This is for us as users to have a reference of what each one of these fields represent. If you're just right here scrolling and you don't know what this thing is, you either have to go to the top to find the header, or this is a good design for a user, they repeat the header every couple of rows. So this plays very nicely for a visual user, me browsing the page, but it will not work so fine for us working as programmers, accessing it programmatically. So that's gonna be the complexity. Let me show you how the read HTML process works. At least for this page, it will get only one table, right? And we're gonna set that NBA table into NBA. There we go. Everything seems to be working fine. All the different values for all these different columns are set correctly. But if you do a little bit more digging, you will find issues here and there. So that's when the process, let me do a quick info here. That's when the process of cleaning your data is gonna start. So for example, field goals, we're expecting it to be a numeric type, 1.8, 0.4, 1.1, etc. But here, field goals, right here, it's an object. And why it's an object? Because every couple of numbers for field goals here, you're gonna have an FG, right? So that's gonna complicate things. If we get NBA.head, 50 elements, we're gonna see that every now and then for field goals, we're gonna have a FG, right? So we will need to clean all the rows that look like this. It's not very hard. You can try it at home. It's a rather simple exercise. So moving forward, we're gonna talk about another table, which is the one in this page, the Simpsons Wikipedia page. And the complexity of this table is also based on the simplicity of visualizing it, right? So one advantage, if you want to improve visualization, you're gonna decrease the simplicity of accessing it programmatically. So in this case, I tried to simplify our view by grouping all these columns, as you can see, but this is gonna be difficult to parse with Pandas. So what we're gonna do is we're gonna read the tables from using the request method. So this is just a variation so you can see that it also works. And we're gonna see how many tables we have. There are multiple tables in this page, right? So for example, up here, these are tables. There are multiple tables in the page, but we're gonna focus, this is another one. We're gonna focus in the one we were just looking, that it's the most complicated one probably here. The one that is on index 1. And why is this table the difficult one to parse? Because these are all nested rows and columns. So this column, for example, is spanning 1, 2, 3 different columns. So you have one column spanning 3 of them. And then you have this row that it's spanning 1, 2, 3 rows. So you have a row span of 3 and a col span of 3. And this is exactly what you're seeing right here. Season, 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 row span of 3. And then you have originally aired 0, 1, and 2, which corresponds with originally aired 0, 1, and 2. Within it, you have season premiere for a row span of 2, right? A total of 2 row span. So you have season premiere 2 times, right? After all this, it comes to data, and you can read it pretty much perfectly. So you can work around it. I mean, it involves a little bit of cleaning, but it's pretty much as expected. Saving it to a CSV, then it's simple because it's all part of a data frame. So again, reading data from HTML pages is absolutely great. I personally use it a lot. I don't use it for projects that are long-term because reading data from HTML is unstable. Today works, tomorrow it might not. I use it for quickly hacking. Whenever I have questions about things, I need to go and pull the data from this thing to quickly, I have a bet with a friend about some given question that we had, and I just go pull this data from the page and we answer it with some code. That's for quickly hacking. Whenever there is a project that involves a long-term run, a more important project, I will stay away from reading the data with pandas and a table, and you can go to a solution that is a little bit more scalable and robust, like for example scraping with a tool like Scrappy. But again, it's a great tool to understand and use. Remember, when you are importing data with HTML, you will sure have a ton of cleaning to do. In this final lesson, you're going to see multiple other examples of external sources of data that you can use, and it depends a lot on your usage, right? So for example, there is this type which is pickling. It's actually a serialization format from Python. This is a pure Python thing. It's a way to serialize objects, to transfer them, to store them in memory, files, etc. I personally never use pickling except from some very, very edge cases, but it can be useful to you. The same thing for some practical things. For example, reading something that it's already in your clipboard. So you go to a page, you Control-C something, and then you try getting pandas to read it. In this case, this will not work if you're using notebooks.ai or Google Colab or an external Jupyter environment, because that's a different computer and it cannot access your clipboard. So just for you to notice. The same thing for SAS files or the same thing for Stata files. This is something that depends a lot of what is the type of data you're getting, what's the software you're using, etc. And finally, this is just one example, but is, for example, the Pandas Google BigQuery extension, which will let you query Google BigQuery directly from Pandas. This is very, very interesting once you get your head around it. There are other projects like, for example, Alpha Bandage that has methods to read financial data. There are multiple other libraries around that will get you these data that you might need. So look for them in libraries if possible, and then you can always resort back to APIs, to network requests, etc. But there are multiple sources to use. And this concludes our reading data course with Pandas. I recommend you to work on the practice. There are a couple of interesting assignments and projects in this course, so I recommend you to look at them and work on them, because remember, the complexity of reading the data doesn't rely, it's not about the actual reading process, because the read CSV, read JSON, read HTML method, they will take care of doing the actual reading. But the complexity might be before reading. So for example, a JSON file that has an odd structure, so you have to analyze it, you have to look at it, how you're gonna flip it, how you're gonna flatten it, etc. Or after reading, when, for example, you read an HTML table and it's completely dirty and you have to clean it, you have to remove columns, rows, etc. So the actual process of reading is simple. The major work happens either before or after the process.